Students, can you see my PPT?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Good morning, students. How are you all?
Fine.
Good morning, sir. We're fine.
So
Fine.
We are
fine.
fine, sir.
Fine,
Did you
Good
sir.
enjoy
morning.
your first lesson?
Fine, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, great. Okay. So we'll move forward this lesson. Yeah. So today we are going to learn about science lesson. Okay. But before starting our topic, we will see what you have already learned. Okay. I will ask you a few questions. You have to answer my questions. Okay. So here we can see various example. Okay. From that example, you have to tell me where work is done and where work is not done. Okay. Are you all ready?
Yes.
Yeah. So what is the first example, students?
Work is not done.
Okay, work is not done. And in the second example,
Work is not done.
Work is not done.
okay. And the third one,
Work is
Work
not
is
done.
done.
Work is done.
done or not done?
Not
Done.
done.
Not done. And in the fourth one,
Work is done.
done.
fifth one,
Work
Work
is
is
done.
done.
work is done. Very good. So you all have understood the concept very well. So now, as you have already studied about the work, today we are going to study about energy in the lesson work and energy. Okay. So students, carefully observe this first example, and can you all tell me why the first plant, what is the difference between first and the second plant?
The first plant got the sun rays, that's why he survived.
Okay,
And the
and what
second
happened?
plant was in and the
Okay,
second plant was inside the house. That's why he didn't get the sunlight. That's why also.
so sunlight gives us which energy? From sun, what energy we got?
Heat energy.
Heat
Heat
energy.
energy.
Okay, heat and light energy. Okay, and the second example, what is happening?
There is no heat energy.
How the paper is burning? Why the paper is burning?
Due to heat energy.
Second, in magnifying glass, I am asking.
Because of the heat energy.
Yeah. So here, what is happening? Light energy is being converted into heat energy. Yeah.
Yes.
Yeah. Now look at this both this example. What you can see in first example,
Man fold.
okay, and in second one,
He carries the weight successfully.
okay, he's able to carry the weight. Okay. So why in the first example he is not able to carry the weight? What he is not
Because
able.
the
You are not
energy was
prepared.
less.
Can you repeat?
He does not have that much energy.
Yes. And the second one,
He has
He had an
energy.
energy.
okay. So with the help of these examples, can you all now tell me what is energy in your own words? You can say. For
The
energy, what?
capacity of body, the capacity of a body to perform work is called energy.
Very good, very good. So the capacity of the body to perform work is called energy. If we have the capacity, we will be able to do the work. If you don't have the capacity, we will not be able to do the work. And the SI unit of energy is joule, and CGS unit of energy is earth. Now, can you all tell me various forms of energy which you see in your surrounding?
Heat energy, light energy,
Yes, some more.
Kinetic energy, potential energy.
electrical energy.
Mechanical energy.
So mechanical energy,
Chemical
heat
energy,
energy, light
sound
energy,
energy.
sound energy, chemical energy, nuclear energy. Okay. So these are various kinds of energy. So today we are going to learn about mechanical energy, and mechanical energy are of two types. First is kinetic energy and second is potential energy. So first we will see what is kinetic energy. So tell me what you can see in first example.
So they are
The
playing
cricketer
cricket.
was bowled.
Okay,
The
so
batsman
what
was
happens?
bowled.
What happens when ball strikes the stump?
The stump,
Blows away. Yes or no?
yes.
Yeah, yeah. And in the second example,
When he strikes this,
I
no, when he strikes the
when striker strikes the,
odds, they get
they also move. Yes or no?
when the striker strikes the game.
Yeah. So uh, when the striker hits the coin, okay, what is transferring from the striker to the coin?
Energy.
kinetic energy.
Kinetic energy. Okay. So this energy which the coin got was due to kinetic energy. Yes or no? So can you all tell me what is kinetic energy? How kinetic energy comes into the object?
The kinetic energy gained by a per- gained by gain on account of on
You can
account
tell
of
in
its
simple words.
motion is called kinetic energy.
Okay,
The energy which an object has because of its motion is called kinetic energy.
very good. So here what happens? The energy which an object has because of its motion is called kinetic energy. Okay. So here you can see the work done by force to displace a stationary object through a distance as is kinetic energy gained by the object. So here you can see as the striker hits the coin, what is happening? The striker is applying the force on the coins. Okay. And by that force, the coins are moving. So striker is doing work on the coins, and because of that work, the coins are moving. So if the striker will do more work, that means if the striker has more intensity, the coins will move more or less.
More.
More, yeah,
More,
yeah. And if we slowly move the striker, what will happen? The coin will move slowly. Okay. So work done by the striker is proportional to the kinetic energy, or we can say equal to kinetic energy. Okay. So kinetic energy is equal to work done on an object. Okay. So now the formula for kinetic energy will be same as the formula for work done, that is force into displacement. Okay. So now we are going to derive the expression of kinetic energy. What is the exact expression of kinetic energy? Okay. So look at this basketball. Okay. So suppose the mass of the basketball is m. Okay. Suppose the mass of the basketball is m, and as you can see, the ball is stationary. Okay. So what will be the velocity of a stationary object?
Zero.
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 Yeah. So the velocity, the initial velocity of the stationary object is zero, and it is denoted by u. Now we are applying force. Okay. Now we are applying force on the object. Okay. So this football is applying force on a basketball, and the basketball moves. Okay. So when we applied force, there what will be there? There will be, yeah, but
Displacement happening.
Final velocity.
Displacement.
so there will be displacement happening. Yes. So when the displacement happened, there was some kind of some amount of acceleration in it, and it took some time. Okay, the time taken for the displacement is denoted by t. And when the ball got displaced, okay, its velocity got changed. Okay, so change velocity or final velocity is denoted by v. Okay, students. So work done is given by force into displacement. Okay. So now we will see the expression for kinetic energy. So work done is equal to force into displacement. Can you all tell me what is the formula of Newton's second law of motion? What formula we got from Newton's second law of motion?
U square is equal V square is equal to U square plus
No,
280.
no, no. That was equation of motion. There were three Newton's laws of motion, na?
F
Yes,
is
sir.
equals to
Law
MA.
of
Yeah, very good. F is equal to ma. Okay. Now we will use Newton's second equation of motion. Can you all tell me what is Newton's second equation of motion?
V square is equal to U square plus 80 square.
No, it is third equation of motion. Second one. First was V is equal to U plus 80. Second was S is
S
equal
is
to
equal to
UT plus.
UT plus half 80 square.
Oh, yeah. Okay. So, however, what we saw, the initial velocity of basketball was
0.
0. Yeah. So, when we will put this in equation, it will become S is equal to 0 plus half 80 square. Now, the equation will become S is equal to half 80 square. Okay. Now, as you can see here, work done is equal to force into displacement. Okay, so here we put the value of F is equal to ma, and in the place of S we put S is equal to half 80 square. Okay, so we got this formula by equation number 1 and equation number 2. Okay, then we will arrange this and we will get m, and we will take a common, so it will become a square t square, and this will become 80 whole square. Then we will use in Newton's first equation of motion. Can you all tell me what is Newton's first equation of motion?
V is equal to U.
V is equal to U plus
80.
80. Right. So this is Newton's first equation of motion. So as you all know, initial velocity was 0. So it will become V is equal to 80. Then we will square on both the side. We will get V square is equal to 80 square. Okay. Then as you can see, V square is equal to 80 square. Yeah. So V is equal to 80. So V square is equal to 80 square. So in the place of 80 square, we will put V square. So as you saw in the example of Karam, that kinetic energy is equal to work done. Okay. So the final formula for kinetic energy will be half mv square. Okay. So kinetic energy formula is half mv square. So now we will see what is potential energy. So as you can see in the first example, okay. So as you can see in the first example, what is happening? Can you tell me what is happening in first example?
The rubber is cold.
Okay.
The
So
rubber is stretched.
okay. So when we stretch the rubber, what happens to the rubber?
The rubber gets to its original position
Yeah,
when we
very good.
stretch
Okay.
or
So it get
loses it.
yeah. So it get back to its original position. Okay. And in this example, what you can see?
In a dam, the water is stored, and when released, the kinetic energy gets convert. The kinetic energies go down
Yeah.
because of kinetic energy down.
And in the third example, what you can see?
A spring is released.
Okay. So as you can see, when we stretch the rubber or we compress the spring, okay, what happens? It comes back to its original position. But why does it come back to its original position? From where does it get the energy? Can you all guess? Why does it come back to its original position?
It
What kind
uses
of
the
energy is
same
that?
energy to come back.
Potential energy.
Potential energy. Very good. Okay, so it comes back because of its potential energy. So can you all tell me what is potential energy?
The energy stored in an object because of a specific state of motion is position is called potential energy.
So because of its position and specific state. So can anyone read this definition? Aditya, yeah, read.
Potential energy. The energy stored in an object because of its specific state or position is called its potential energy.
Very. So there are two types of potential energy as we saw. First is gravitational potential energy and second is elastic potential energy. Okay. So what will be the example of gravitational potential energy from the previous, which we saw from the previous slide?
The spring.
Spring.
Spring. Think. For
Another
gravitation,
dam,
dam one, yeah. And for elastic potential energy,
spring and rubber band.
very. Okay. So now we will see expression for gravitational potential energy. Okay. So suppose this mass of football is m. Okay. So when we apply force, okay, when we apply force on this ball, okay, in upward direction, it moves upward and there is a displacement. Okay. So here displacement will be in the form of height. Okay. So displacement will be in the form of height and acceleration will be in the form of g. So can anyone tell me why acceleration will be in the form of g, not a?
Gravitational force.
Yeah, so because work is done against the gravity. So force will become mass into acceleration, that is mg. Yeah. So work is equal to force into displacement. So here work done will become mg into h. So work done formula will become mgh. Okay. So amount of potential energy stored in an object because of its displacement. So potential energy will become mgh and the amount of displacement. Okay, so basically if the height of the potential, if the height of an displacement is, if the height of the, suppose the displacement which took place is more, so potential energy will be more or less, the displacement is more.
The potential energy will also be more.
Yeah, so as you can see the formula of potential energy mgh. So if h increases, the potential energy will also increase. Okay, and if h decreases, the potential energy will also decrease. So here are two examples. Okay. So from this example, can you all tell me how potential and kinetic energy are related to each other?
When the stored water is released, the potential energy gets converted into kinetic energy because of its motion.
Very good, very good. Okay. So as you can see, when the water is stored in a dam, okay, it is at top position. Okay. So it has some kind of potential energy. So as soon as the dams, okay, the doors of the dams are open, the water flows down and the potential energy is converted into kinetic energy. So what we have learned? We have learned energy, and what we have learned? What else?
Mechanical energy and mechanical energy.
In detail, what we have learned?
Kinetic energy and potential energy.
So we have learned kinetic energy and potential energy. Okay. So now there is an evaluation for you. So in this MCQ, there are one or more correct option. Okay. So you have to tell me what are the correct answers. So for the work to be performed, energy must be, which all options are right?
So the
Transform from one place to another.
Yes, and
concentrated
no.
Transform from one
from
type to
one type
another.
to another.
Yeah. So as you saw, yeah. So as we saw the example, what of potential energy being converted into kinetic energy. So transform from one type of energy to other. And what is the unit of? Sorry, joule is a unit of.
Force and power.
Force,
Very
work,
Force and
power.
energy.
yeah. Work and energy. Yeah. Force is force. Ka, what is the unit of force?
Newton.
Newton.
Okay, very good. And third one, the potential energy of your body is least when you are
Sleeping on the ground.
Sleeping on the
Sleeping
ground.
on.
On the ground.
sleeping on the ground. Okay. So This is a small word wall activity. Okay, I will share the link. You just have to open this link. Okay. So here what we have to do. We have to just differentiate between potential and kinetic energy. Okay. So there are various examples of potential and kinetic energy. You have to drag that examples into the particular column. I will share this link in the chat. Can you all access the link?
Yes.
Yes, sir.
So open the link now.
Yes, sir.
Can you all see this kind of interface?
Yes, sir.
Okay, so you have to drag the examples, okay, into the potential energy and kinetic energy. Tell me when all of you have finished. Are you able to do it?
Yes.
Yeah. Have you all completed?
Wait a minute, sir. Yes, sir. Done.
Yeah.
Yes,
Sir,
sir.
can we
So
submit?
yeah, submitted. So can you all tell me where this flowing river will come?
Sir, in kinetic energy.
Yeah. And this dam,
Dam potential energy.
flying birds,
Kinetic energy.
Energy.
and this moving skateboard,
Kinetic energy.
and this one uh,
Potential
car at the
energy.
top,
Actual energy.
Kinetic
person
energy.
walking,
Kinetic energy.
and this a stretch board,
Kinetic energy.
a moving vehicle, where potential energy,
Kinetic.
and this one a boy at the top.
Potential.
Stretch rubber will be potential.
Potential.
Very good. So did you all enjoyed the game?
Yes, sir.
So now we will see one video. Just a second. You have to observe the video carefully, and tell me what all things you have observed. Okay.
T minus 90 seconds and counting. All systems are go. We're about 90 seconds from the launch of Space Shuttle Discovery.
Can you hear the video?
Yes, sir.
Yes, sir.
T minus 60 seconds and counting. We're transferring to orbiter internal power at this time. Discovery is now running off its 3 onboard fuel cells. Coming up on a go for auto sequence start. And we have a go for auto sequence start. Discovery's onboard computers have primary control of all the vehicle's critical functions. T minus 17 seconds and counting. 15, 12, 11, 10, 9, 8, 7, start, 2, 1, booster ignition, and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond. Solid rocket booster separation confirmed. Guidance now converging. Discovery's onboard computers commanding the main engine nozzles to swivel, aiming the shuttle for its precise target in space for main engine cutoff.
So students, you observed the video. So what kind of energy is required for the rocket to start?
Heat energy.
Which energy?
Heat energy.
Yeah. But in our terms, what we have studied, potential energy. Okay. So as soon as the rocket takes off, potential energy is converted into
Kinetic energy.
kinetic energy. Okay. So here the scientists have to calculate, okay, the potential energy very carefully. Okay. The particular amount of energy which is required for the rocket to leave the Earth's gravitational pull. Okay. So lots of calculation is required for that, and according to that, okay, potential energy is being calculated, and uh, that much required energy is given to the rocket. Okay, and as the rocket takes off, it leaves the Earth gravitational pull. Okay, and it gets into the orbit, okay, of the planet or satellite. Okay, so what all qualities, okay, a scientist have? Can you tell me the qualities of a scientist? Our Are
Good
scientists lazy?
calculation.
Good in math.
Yeah, so good at calculation, maths, and are they lazy?
Science.
Yes, sir. They're very
Yeah,
active.
they are active, they are hardworking. Okay, so can you all tell me all these qualities? Okay, how can these qualities of a scientist can help you in your life, in your future? It will not help you. The qualities which the scientists have,
For our ambition.
yeah, to achieve your goal. Okay, whatever goal you have set can be achieved through determination, persistence, accuracy. Yes or no? So now there is a small assignment for you. You have to list down various examples of kinetic and potential energy that you observe in your surrounding. Okay, will you do that for me?
Yes, sir.
Yeah. Thank you.
Yes, sir.
Thank you, sir.